Okay, so up till now, what we've talked about with sets has just basically been terminology, getting our fingers dirty as we've been playing around with the sets. Now what we're going to do is we are going to talk a little bit about some of the operations, some of the things we can do. So it's kind of like when you're in elementary school and you first learn how to write the numbers. We've just learned how to write the numbers. Now we're going to learn how to add and subtract and multiply and divide and do things like that with the numbers. So what I've just handed you, and if you're watching the video, what you can print from Canvas is I handed you a sheet that has a bunch of what's called Venn diagrams. Venn is named for the mathematician who started set theory because he must have been very bored. There was no internet. So this is probably how this person spent their days. So the first thing we're going to do is we're gonna go one at a time. I'm gonna show you what the Venn diagram represents. And then we're going to look at, there are 5 different operations that you can perform with sets, or at least that we are going to learn to perform with our sets. So on your Venn diagram, you have all of these pictures. They're in a rectangle. And then there's 2 circles in them that overlap. So let me tell you a few things about what you're looking at. This rectangle right here, what it represents and is called the universe. When you're doing your problems in my math lab, or if you're looking at the book, they don't write out the word universe. They'll just put the letter U there. Usually it's bolded to indicate that. So you might be saying, well, that's great. What is the universe? Well, in sets, the universe is everything being considered. So in any of the problems that you do, a universe is going to be told to you. Now, I know we think universe is huge and expansive and infinite. The universe can be any size in sets. The universe can be the empty set. The universe could be everything in the universe. Okay, so don't take it to be size. Most of the sets we work with are going to be nice and finite and have 10 or 12 things just to keep it interesting. But so that we're not doing these things all day. Then each of these circles represents a set. And usually what you'll see is you'll see them labeled with their letters. So this might be set A, and this might be set B. And then whatever's in the circle represents what is in that set. Now, this is not how it would usually be labeled, but just for your notes on this first one, I'm just going to write set A, set B. So the Venn diagram, because we think visually and we're really good with pictures, so the Venn diagram provides us a nice way to be able to visualize what's going on with sets as we think about them. Okay, so there are 5 things that we will talk about. There's going to be 5 operations that we deal with as we go through this. So the first one is called the complement. I always spell this wrong, okay? It's the complement of a set. You can move to a new Venn diagram as we do this. Unfortunately, I didn't give you a Venn diagram with just one set in it, with one circle in it. So we're going to use one of these and we're going to ignore the other circle because the complement only deals with one set. Okay. So the complement is everything not in the set. I'm going to draw in just a second. I'm getting everybody a second to write this down because I get excited. I don't know if you can tell, and I don't want to run out ahead of anybody. The complement is everything that's not in our set. So here's my Venn diagram. This is going to look like one of the ones that you have. And so here's my universe. Put a little U up at the top. And I know there's 2 circles on there. We're going to ignore one of them. And we're just going to deal with set A. So if this circle right here that I'm tracing around, this left-hand circle, the whole thing, if that is set A, then what I shade now and whatever color comes out of this pen is going to be the complement. And it's everything that's not in set A. So if this is set A, then the complement is everything. It's like elementary school again, I'm coloring. It's beautiful. The complement is everything outside of the set A. So you should have the full circle for set A. It should stay white, nothing in there. And then however you're shading or whatever you're doing, you shade everything outside in the universe. That is the picture that represents the complement. The complement is everything outside of your set that's in the universe. The complement, the symbol that we are going to use, in math, there are two symbols. Our book uses this. We use A with a little apostrophe right there. That means the complement. That means everything outside of set A. Once you're done writing that down and having all the fun of coloring in the circle, here's what we're going to do. Here's my universe that we're going to deal with for a bunch of problems. My universe is going to be the numbers 1 through 10, just to keep things simple, but there's enough elements here that we can have a little fun. No, this is in your notes. We're going to do a few examples. I mean, we could put them on a Venn diagram. I mean, if we need to, that might be a fun thing to do. But I'm just setting up a problem that we're going to work, and we're going to work all the operations to begin with this universe. And I'm going to define 4 sets for you. I'm making this up. This is the problems we're going to deal with, and we're just going to define them up front so that we can use them a whole bunch. Okay, so on a piece of notebook paper at the top or in the middle, wherever you are, you're writing your universe 1 through 10. And then here's the 4 sets that we're going to do things with. Set A is going to be 1, 2, 3, 8. Set B is 1, 3, 6, 7, and 8. Set C is 1, 3, and 4. And then one more. Set D is 5, 7, 9, 10. I'm going to give you a minute to write that down. I know I'm way ahead of you. As I mentioned last time, while writing, I'm gonna reiterate this. I mentioned last time, while you can write the elements in sets in any order, when we're doing these operations, it's going to, because you can see everything I've got here is in number order. It's going to be really helpful if you take the effort to put things in number order, because when we're doing the operations, it's easier to see how things line up. So here's my first example. What I'm going to do is, what's the complement of A? What's the complement of A? So here's my universe. This is everything we're considering. There is nothing that we're going to consider that's outside of this universe of 1 through 10. Set A is 1, 2, 3, 8. So now what is the complement? Well, let's just walk down the line. Is 1 in A? Yes, can't be in the complement. Is 2 in A? Yes. Is 3 in A? So far boring. Is 4 in A? No, so it's going to be in the complement. Okay, the complement is everything that's not in our set. Is 5 in A? And you'll get quicker at this. 6 is not in A. 7 is not in A. 8 is in A. 9 is not. 10 is not. There you go. Any questions about how I found the complement? Yeah.
So isn't it almost like when you hear something when it's a bit better, so like they say like one complements like French fries. stuff than that?
That's complement. It's a great question. I don't, okay,
That's
so
the one
I understand.
Mhm.
I think it's spelled the same way, but that's not the exact thing that's going on. A way to think about this is if I smush these two sets together, if I smush A and the complement together, you should get everything there is. Okay, so everything in the universe is either in a set or in its complement. They have to be one of the two places. Great question. I appreciate the questions. We're trying to sort through these things. Any other questions? So it's spelled the same way. No, the other complement, because I usually make a joke of this, but I'm less funny now that I'm older. Okay. When you spell it with an I, isn't that when you say something nice to somebody? I thought it was. Yeah, and then I don't know what I'm just not saying your name because we're recording, so I'm trying to maintain privacy. So when I say what you said, I think that one's spelled with an E too, but it has more the connotation of it goes well together.
Right.
Not, so these things we wouldn't say go well together. They are just, they make a whole would be kind of the connotation. All right, excellent. I love it. So here's what I would like you to do, please. This is set B. Just write down what B complement is. Remember, the complement is the stuff that's not in the set. So here goes. I'm just going to go element by element in my universe. 1 is in B, so it's not in the complement. 2 is not in B, so it goes in the complement. 3 is in B. 4 is not. 5 is not. 6 is. 7 is. 8 is. And then finally, 9 and 10 are not. That should be your complement. And again, the nice, easy way to check when you're working your homework or your quiz or when you're on the test is when you smush these together, that should be the universe. That's everything. You're either one or the other. Let's do one more, and then we're going to go on to the next operation. The last one I'd like you to do is D complement. Okay, so I'm going to try to get a little quicker at this. If I confuse you or lose you, please let me know. This is 5, 7, 9, 10. So that means the complement has to be 1, 2, 3, 4, not 5, 6, not 7, 8, not 9, not 10. And so there's the complement. Okay. The more you do these, the quicker you'll get at them. It's just practice. That's all it is. Are we good so far? Any questions about the complement? Okay, beautiful. Love the agreement. Okay, the next set operation is called the intersection. The symbol, the operation symbol, like a plus sign or a minus sign, the operation symbol for the intersection is a upside down, it's like a rainbow, upside down U. So here's my Venn diagram. Here's my universe U. This is my set A. This is my set B. What happens at the intersection of roads. They cross over, right? Okay. So where you were trying to find a common usage for complement, we can use the common usage for intersection. Okay, intersection is what the sets have in common. Or we could say where the sets overlap. Or we could say the elements that are in both sets. Okay? Any way that you want to say it, that's what the intersection is. What the sets have in common, or we could say the elements that are in both sets, or where the sets overlap. So I'm going to try to do a little fancy coloring here. I know that you didn't come prepared with different color pencils, so we're going to also shade diagonally or draw lines diagonally, and you're going to tell me where on my Venn diagram the intersection of A and B is. So what we're trying to figure out here is what is A intersect B. That's how we would write it. Here's set A, here's my intersection symbol, here's set B. So I'm going to put the stuff in set A as blue. Okay, and I'm going to shade diagonally this way. Okay, so then I'm just shading, or I'm drawing some nice blue lines here inside set A. You with me? That's my circle, that's my set A. That's everything in set A. Set B, I've got red, but I know you don't, so I'm going to shade in the other direction. So instead of going left to right down, I'm going to go left to right up. So in B, I'm going to shade this direction in red. So everything in B, that full circle, is now red. So if I asked you to run up here and point to where you think the intersection is, what would you point to on the Venn diagram? The middle stuff, where both colors are, or where both directions shading are. I'm going to make it a little darker so that on your notes you'll know exactly where it is. This football-shaped piece right here, this is the intersection. It's where the two sets overlap. It represents all the elements that are in both sets. It is what the sets have in common. That there is A intersect B. We good with that so far? I'm going to erase this so we can do some problems involving the intersection, but I don't want to erase this too soon. Okay, so again, we're going to use our universe. We've got a whole mess of sets that we've got right now. So here we go. My first problem, I'm going to do A intersect B. We're dealing with those sets over there, okay? So I'm going to meander back over to this side of the board. Here's my set A, here's my set B. What do those sets have in common? They both have 1. What else do they both have? 3 and 8. Does anyone not see how we got the intersection out of those two sets, A and B, over there? Sure. In fact, let me draw some lines. Maybe this will be helpful. So here's my set A, here's my set B. I'm asking for the intersection. The intersection is what elements are in both sets. So I'm just identifying the ones that are in both A and B. So I see 1 is in both A and B, 3 is in both A and B, and 8 is in both A and B. Notice 2 is only in A, so it's not part of the intersection. 6 and 7 are only in B, so they're not part of the intersection. They don't matter. Just comparing the two, exactly. Good word. Yes. Any other questions? That's beautiful. Okay, then what I would like you to do, please, is I would like you to do A intersect C. So A intersects C, here they are. What elements, when I compare them, do these two sets have in common? 1 and 3. 2 and 8 are only in A, 4 is only in C, so it is 1 and 3. We good? I would like you to please do D intersect B complement. We've already found B complement, so there's no extra work right now. All right, here's D, it's 5, 7, 9, 10. Here's B complement, 2, 4, 5, 9, 10. What do those two sets have in common? The 5, the 9, and the 10 are in both of them. Yes, indeed. I've got one more example of the intersection I'm going to have you do. So if there's any questions before we move on to the third of the 5 operations, let me know. The last one that I would like you to do, please, is C intersect D. C intersect D. What do C and D have in common? Nothing. So what is the set that represents nothing? Empty set. So I'm going to write, I prefer just to stay consistent. I use my braces. Again, if you want, you can use the null symbol. I'm just reiterating this because I do take a slight deduction on the test if you do this. This is not the empty set, okay? If you use both. Because, is this set empty anymore? No, it's got something in it. Okay, so I know I understand more is better. I'm going to throw every symbol I know at the Berkster, but when you do that, you're accidentally communicating something completely different. If we went further talking about sets other than just the very surface level thing, this has an explicit meaning in set theory, which would be really fun. And yeah, that's what I did in college, which who knew that was a thing. Okay, so that's the intersection. Do we have any other intersection questions? Okay, here is the third operation of sets. It's called the union. Here's my universe. Now, we gotta be careful. The universe is the letter U. The symbol for a union, it looks like a U, but it doesn't have a tail, okay? So don't get, I understand you want to write the tail, but the union symbol does not have the tail on it, okay? It's just a cup. So if we think about the language use of union, there's a couple situations when people get married, that's the union, okay? Joining together. When you work, like if you're a teacher, you might join a teachers union. That is the group of all people who are doing something. So a union, the way you find a union is it is everything in both sets. So A, union B. This is how it would look. If I was asking you A with that union symbol, B, I really don't need to do any fancy coloring on the union. It's everything that is in both sets. So I'm just going to, here we go. Anything that would occur in both those circles is in the union. Great. We'll do a couple of union examples. So again, here's my universe. There's my sets. We're getting good mileage out of this. So now I want to figure out what A union B is. Okay, A union B is just everything in A and everything in B. If something occurs in both, you don't have to write it twice. Okay, you just write everything one time. So here we go. Tell me the list of things that are in either A or B. I will not mark you wrong on the test. If you put things, out of order, I get it. I think my math lab's a little fussier though. Okay, so be careful. But it does help me not go blind when I'm grading the test if you put them in order. But again, it's not something I'll mark you wrong on. Okay, so I would like you to please do B union D. All right, so B and D are over there. So give me the list of things that are in either B or D. Well said. Leave a little space after this problem. We're going to come back to that in just a minute, but I've got one more union problem for you to do. Let's go ahead and do C union B. Okay, C union B. You can see B and C over there, and it's going to look like 1, 3, 4, 6, 7, 8. I've got one more problem we're going to do related to this, and then we'll move on to the fourth. We're going to do 4. We'll do the fifth operation when we come back next week. I have another example I'd like to get to, but if not, that's where we'll start when we come back next week. We did B union D, but we can combine these operations, okay? And you're going to see that when you go through your homework. So I've got B union D. You might be asked to do B union D in parentheses with this symbol. Now, remember, what does this symbol mean? We learned this a minute ago. Complement. So if you're asked to do this problem, it's like I put this on the test, or if this is a homework problem, if you're asked for B union D in parentheses with a complement, all that means is, just like arithmetic, the first thing you're going to do is what's in parentheses, which we did, the B union D. And now what I would like you to do, we've already done the B union D, you did great. What's the complement of the B union D? Okay, there's the set, we've written it out. What's the complement of B union D? So B union D is 1, 3, 5, 6, 7, 8, 9, 10. Remember, the complement is everything that's outside of that set, everything in the universe that's not in this set. So what elements are in the universe that are not in this set right here? 2, 4, that's it. 5, 6, 7, 8, 9, 10, everything else is there. I'm calling it audible here because I want you to be able to do as much of the homework as possible. So when you're going through the homework, the two operations we have not talked about yet, okay? Set subtraction. So if you come across a problem that has subtraction in it, just skip it. And then what's called the cross product or set multiplication. We haven't talked about that. What I'd rather do is I'd rather take our three operations we have and do another different style example that there's some of on the homework. Okay, so we'll come back, leave a little space in your notes because we'll come back and we'll use these same sets again when we talk about subtraction. So if you have a little space, you'll be able to just add it in right at the end. Pull out your Venn diagram sheets. So what we're going to do is instead of being given the sets as sets that are listed, we're going to have this Venn diagram right here. So this is, we'll call this example 2. Here's my universe. Here's my set A. Here's my set B. And what I'm going to do is I'm going to put elements in different places. So in this part right here, I'm going to put an A and an I. In the middle part right here, I'm going to put an F, a C, and a J. In this region over here, I'm going to put a D, a G, an H, and a K. And lastly, in this part outside that is like the border of the puzzle, I'm going to put a B and an E. So instead of giving you sets, I'm giving you the universe this way right here. So we're going to spend we've got 7 more minutes. I'm just going to derive some examples from this, and then we'll call it a day. So what I would like you to do for me is I want you in roster form to write down what is set A. What is set A? Try your best to put it in alphabetical order, but I understand if that becomes laborious. Okay, so what are the elements that you listed in set A? A, C, F, I, J. Yes, the A is this full circle right here. I did not ask for anything else. I didn't ask you to compare it or intersect it or anything. So it is these 5 elements are in that circle. Any questions about where we got those from? Okay, then what I would like you to do now is I would like you to tell me what B complement is. Okay, remember the complement is everything that is outside of my set. So what is the complement of B? So here's set B right here. What is the stuff that is outside of set B? A, B, E, I. Again, as long as you have those 4 letters, I'm not concerned about the order. I prefer alphabetical. It's easier to read, but it's not, in the scheme of things, a big deal. Are we doing okay so far? All right, I just got a couple more. I know we're running a little low on time, so bear with me. The next one I would like you to find is what is A intersect B? What elements did you write down from the intersection of these 2 sets? C, F, yep, just the stuff that's in the football right here where the 2 sets overlap. 2 more problems. Okay, here is the second to last problem for the day. Write down A union B. Yes. Yes. This stuff right here, great question. This stuff right here, when I look at it this way, it's part of B, right? And then when I look at it this way, it's part of A. It's the stuff that both sets share. Okay, great question. Good clarifying. Remember, the union is everything in both sets. So you're listing in some order everything that's in both circles. So I'm going to do my best here. We've got A and then C, and then I see D and F and G and H and I and J. And I think the last one is K. So as long as you have these 1, 2, 3, 4, 5, 6, 7, 8, 9 elements, basically everything except B and E, then you are good to go. And here is the very last problem related to that one, but try to see it on the picture. Okay, try to see where that's going to help you in the long run in this chapter. So if I say, what's A union B? Complement. What's everything outside of the union? Everything outside of both sets. Okay, so looking at the picture, what region here represents everything that's outside of the union? Yeah, this stuff right here, right? Anything that's in the border, if we were building a puzzle. Okay, this is kind of like one of those kid puzzles that has like the 3 big pieces that when they're first learning coordination, and then here's the thing they're putting in it. So the only thing that's there is B and E. Awesome. You did great. Let me end the recording, and then you can pack up and make all the noise you need to make.